equation right here. Okay, so if I'm completing the square, okay, I don't want an a there, right? So what would I do to get rid of that? We could divide it out. And I'm going to have to divide it out to the whole thing, okay? So let's say I have, man, I hope I have enough room. I'm going to divide everything by a, so that would leave me with x squared plus b over a x plus c over a equals 0, right? Because I would be dividing by a. All right, now if I'm doing completing the square, I want to get the c over a on the other side, right? Because I need this here. So I'm going to do x squared plus b over a x. And then I know I'm going to be adding something, so I'm going to leave some space for that. Equals, and then when that's c over a, it'll be negative c over a. And I'm going to be adding something there. Okay? All right, now what do I have to add to both sides? It's this middle term squared, divided by 2. Sorry, the middle term divided by 2 squared. So b divided by a divided by 2, isn't that just going to be b over 2a? Okay, so I'm going to add b over 2a squared to both sides. Okay. Okay, now I have over here, this is a perfect square trinomial, right? This would be x plus b over 2a squared equals, okay, now over here I got to do some figuring, okay, because I have to square b over 2a, and then I have to add it to negative c over a. So I'm going to do that in 2 steps. So negative c over a plus, if I square b over 2a, I get b squared over 4a squared. Now in order to add these together, I need to have a common denominator. Okay, so I can turn this denominator right here into 4a squared if I just multiply it by 4a over 4a, right? So now I have x plus b over 2a squared equals, now I have negative c times 4a. I can just write negative 4ac plus b squared all over my common denominator of 4a squared. Okay, all right. Now I can square root because I'm trying to get x, right? So I square root to undo the square, and then when I come over here, I square root the whole thing, but I have to make sure that I do the plus or minus square root, right? Okay, so now I have x plus b over 2a equals, now I can't take the square root of the numerator because the numerator itself is not a perfect square. B squared, yeah, but it's a sum. It's a binomial, okay? This itself is not a perfect square, so I have to leave that under the square root. And I'm going to rewrite it so b squared is first. So I have b squared minus 4ac over, now my denominator, I can square root that, right? The square root of 4 is 2. And the square root of a squared is a. Okay? So next, the only thing left to do is get your x by itself. so we can subtract b over 2a. And since I have common denominators, I can just do all over 2a, right? So if I subtract b, it'll look like negative b plus or minus square root of b squared minus 4ac, and the common denominator is 2a, all over 2a. I did, but they're common denominators. When I subtract fractions or add fractions, I need common denominators. So I would have negative b over 2a minus this over 2a, which is, I could just put it together, all over 2a. How did I get this b? This one? B squared. It came all the way back from completing the square where I had to cut this in half and square it. B squared is right here. Here I needed a common denominator, okay? I'm not going to make you do this, okay? Like, I'm not going to be like, hey, derive the quadratic formula, go. I just wanted you to see, where is this coming from? Because someone could say, hey, this is it, but where does it come from? So this is a plug-and-go way to solve, okay? So I like to use Thanksgiving as an analogy. Completing the square is cooking Thanksgiving dinner from scratch. You're going to roast the turkey. You're going to hand mash the potatoes. You're going to cook everything yourself, okay? The quadratic formula is the TV dinner version, the one you buy in the grocery store and they're frozen, you know, have the turkey and the gravy and then you just put it in the oven. That's the quadratic formula. All you do is plug in numbers and boom, you get your answers. Okay? So that's where it comes from. So in this big box, we'll write it large. X equals, here it is, x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And so we just need to know A, B, and C. Okay, and the song to remember it is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I didn't make it up, okay? I'm just the messenger. All right, let's use it. And the way we do this is going to be different now that we have Desmos and not a TI-84. Okay, so it's going to feel, if you remember doing this in Algebra 1, this is going to feel different. Not a bad thing, it's just going to be different. Okay, so I'm going to write this again at the top because it's just weird that we don't have it. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And yes, you are going to have to memorize this for the test. You won't be given it. You'll have to know it. Okay? You'll either have to know it or you'll have to derive it yourself. Okay. All right. So the only way that we can accurately plug in numbers is if our equations are in standard form. Ax squared plus bx plus c equals 0. Okay? Once we have that form, then we have the correct numbers to plug in. Okay, so example 1 is set up really nicely for completing the square. Okay, that's how we would want it if we were doing that method. But we want that 12 on the left side so we understand what a, b, and c are. Okay, so x squared minus 4x minus 12 equals 0. Okay? Okay, so you have to accurately identify A, B, and C, and you can write it down. This is the only example that I'm going to actually write A equals B equals C equals. But you want to pay real close attention to the signs of the numbers, okay? Okay, so your first step, what you have to show your first step is your substitution step, okay? So that's where You literally just insert numbers into the quadratic formula with parentheses. Okay? That's your sub-step. You need to have that. So if I do that, x equals negative b, and b is negative 4. So I have negative 4 plus or minus square root of b squared, so negative 4 squared, minus 4 times a, which is 1, times c, which is negative 12. Okay, now notice when I did this, my square root wasn't long enough. So I got to fix that. You have to make sure your square root goes over your whole expression, or it's not technically right, right? Okay, all over 2a, so 2 times 1. Okay, that's your substitution step. Now, even though Desmos has the capability for you to type this whole thing in, right? You could do that. You don't want to, though, okay? Because we want to see parts of this along the way. All right, so what you're going to evaluate first is this stuff under, well, sorry that that's all smudged. The stuff under the square root, that's called the discriminant. We'll talk about that in a minute. But that's what you type in the calculator first, and you do not include the square root, just this expression. Okay? So what that looks like, you need the parentheses and all, okay? Because if you miss them with the negatives, it's not going to calculate right. So negative 4 squared minus 4 times 1 times negative 12. Okay? And it tells you, all right, that's 64. All right, cool. So down here, x equals, now I can simplify this a little bit. Negative 4 is just 4. Plus or minus the square root of 64 all over 2. Okay? Notice I'm keeping x equals. You got to keep that going. You're maintaining equality. Every line I maintain the x equals. Okay, now can we do the square root of 64? Yes. Okay, that's 8. Plus or minus 8. So x equals 4 plus or minus 8 divided by 2. And now we can actually do that. You can add 4 and 8 together, and you can subtract 4 and 8. So we continue. So we get our two answers. So first we're going to do 4 plus 8 divided by 2. 4 plus 8 is 12. Divided by 2 is 6. So one answer is 6. Whoops, sorry. And then the other one we're going to do 4 minus 8 divided by 2. 4 minus 8 is negative 4 divided by 2 is negative 2. So the solutions are 6 and negative 2. Okay? That one happened to work out. Yes, you could factor it. This one was factorable. Okay? But using the quadratic formula gives us that. Okay? Is this how you did it in Algebra 1? Did you do it piece by piece like this? I hope so. I hope so. All right. I need to separate my work here. All right. Let's look at example 2. Okay? So get everything on one side. We have to get our standard form. So we need the 12x on the other side. We need the 30 on the other side. Equals 0. Okay, you can identify A, B, and C if you need to, or just understand what it is and plug it in. So x equals opposite B. B is negative 12. So we have negative 12. Plus or minus big long square root b squared, so that would be negative 12 squared. Yes, the parentheses are necessary, because if I didn't have them, that wouldn't calculate correctly. Yes, ma'am? That's if we are going to do completing the square. We have to get rid of the a. When we do quadratic formula, all we have to do is know what a is, and we just plug it into this formula. Okay? So there's less work on the front end, but there's more work like throughout the process. Minus 4 times a, which is 3, times c, which is negative 30, all over 2a, so 2 times 3. Okay. What we put in the calculator, make sure that that's dry. 2a. All over 2a. Okay? And then the discriminant, this is what I'm going to put in the calculator. And the cool thing about Desmos is once you do it one time, all you have to do is change the numbers. So this is negative 12 squared minus 4 times 3 times negative 30. There we go. 504. All right. So x equals positive 12 plus or minus the square root of 504 all over 6. Okay. Now I get the number 504. I don't know. Is that a perfect square? You can just type it in and see. Do y'all know how to do a square root in Desmos?
It's on the
Oh, it is a button. Or I like to type. If you type SQRT, it just appears. Squirt. SQRT. So 504. Oh, it's not a perfect square root. It's a terrible irrational number. Okay, so that means we have to simplify it. All right. I'm going to get I don't want to write on this because I don't want to cloud this up. Okay. Is there a perfect square factor inside of 504?
most likely. 9?
9? Well, yeah. 4, yes. It will divide by 4. And also it'll divide by 9 because if you add the digits, you get a number divisible by 9. So I know this is 9 times something. 56? Okay. So the square root of 9 is 3. Now, let's look at 56. Is there a perfect square factor inside of 56? It's 4. 4 times 14? So 3 times the square root of 4 times 14. And the square root of 4 is 2. And there's no perfect square factor inside of 14, right? So it's just 6 root 14. So x equals 12 plus or minus. That beats drawing a giant tree, right? That's why I want to get away from the trees, because they take up a lot of space and time. All over 6. Okay. Now, there's going to be no way that we can add 12 to 6 root 14, right? We can't do that. Okay? So, and we don't necessarily end here. What we do now is we look at this triangle of rational numbers, and we ask ourselves, will all 3 of these divide by a number? If the answer is yes, we do it. If the answer is no, if only 2 of them will divide, then we don't do it. Okay? All 3 of them will divide by 6, right? So we're going to divide it all by 6. So x equals 12 divided by 6 is 2 plus or minus 1 root 14, so I can just write root 14.
But can we put the 1?
You can, yes, you wouldn't be wrong. And then all over 1, also something I don't need to write. So the answer is just 2 plus or minus the square root of 14.
So if we were to put 1, like we would put it over 1, it wouldn't be 1?
No.
Okay.
So one of our answers is 2 plus the square root of 14, the other is 2 minus the square root of 14. Okay? All right. We good so far? Any questions so far?
That's how we write all our answers?
Well, yes, if we have an irrational number, we can't actually continue. Like this one we could continue because the square root of 64 was 8. So I could do 4 plus 8 over 2, 4 minus 8 over 2. Here I can't. So the best I can do is try to simplify the rational numbers and move on. Okay? All right, if we get something like 3, we want to use the quadratic formula, we still need this, right? So we're going to have to manipulate this. We're going to have to distribute the 2x and then get the 12 on the other side. So that would be, what, 2x squared plus 4x. Can we do this all in one step? Can I just add 12? Okay. Okay, now, we have A, B, and C. But also remember, we're solving. There's a way you can make this a little easier. Do you see it? Yeah, you could just divide all these by 2. You don't have to. You definitely don't have to. But you're going to work with easier numbers. Why didn't we do that with the other one? Because I wanted to show you, because I didn't want to jam-pack too much stuff in one problem. Yeah. You know, Edith, was that where you were going with your question? That might have been where you were going with your question. Sorry. Could we have done this in example 2? Yes, we could have. Okay, but only if you can divide out everything, all right? So I'm going to go ahead and take that route and divide it all by 2. So I have x squared plus 2x plus 6 equals 0. And now we can plug that in to our substitution step. So x equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 6 all over 2a. So 2 times 1. Okay. All right, now I go to the calculator. Honestly, you might not even need a calculator for that one, but we do it anyway. Discriminant goes in the calculator. 2 squared minus 4 times 1 times 6. And we get negative 20. Oh, negative 2 plus or minus the square root of negative 20 all over 2. All right. What happens in Desmos if I type square root of negative 20? What does it say? I don't even know. Error? Oh, wait, I had caps lock somehow. SQRT negative 20. Undefined. Yeah. Yeah. Because you can't take the square root of a negative in the real number system, right? Okay? So what this means is that there is no real solution. There is a solution in a different number system, which we get to learn about tomorrow. But for right now, since our discriminant was negative, the number under the square root was negative, I know that there's no real solution. Okay? Because real quick, just to show you, if I try to find the zeros of the graph, right? Let me type the function in here. Y equals x squared plus 2x plus 6. Graph doesn't touch the x-axis. right? There's no real zeros, so no real solution. Until tomorrow. Tomorrow there will be one. All right. Can you all try number 4? You try number 4, okay? Number 4 is not difficult. I know you can do it. We'll go over it in a second.
No, that's yeah. It's 36 minus 36. That's stupid. So then there's that's 9 times 3.
I don't know if you catch it.
So just to make sure we all have the right discriminant, what is the value of the discriminant, the number under the square root? 0. And what's the square root of 0?
0.
Yeah. Positive square root of 0 is 0. Negative square root of 0 is 0. So how many answers does this have?
No.
It just has one answer. The 6 plus 0 divided by 2 is 3. 6 minus 0 divided by 2 is 3. There's one solution, and it's the number 3.
And you also could have found that by factoring.
Yes, exactly. You could have also found that by factoring. That's a discussion we're going to have toward the end of the unit, is how to look at a problem and decide what is the easiest way to solve this. Yes, for this one, quadratic formula would not have been the easiest way, but I'm trying to prove a point, okay? You have 4 examples here for a reason. We're trying to prove a point, okay? And I highlighted this stuff for a reason, okay? So let's come over here. The discriminant, not discriminate, discriminant, okay? The discriminant of a quadratic equation in standard form where a is not equal to 0 is the stuff under the square root, which is b squared minus 4ac. The stuff we type into the calculator. Okay? That's called the discriminant. And sometimes we don't need to solve. Sometimes we just want to know how many answers and what kind are they. Okay? So this little table will help us see that. So b squared minus 4ac, when that is greater than 0. Okay? So let's take a look. When our b squared minus 4ac is greater than 0, that's example 1 and example 2. Right? Whoops, sorry. Zoomed in a little too much. Okay. How many solutions did we have when they were greater than 0? When this was 2. Right? There's 2 solutions. So I'll write 2 real solutions. Okay? But we're also going to add something else here, because in one case my positive number was my discriminant was a perfect square, and in the other case it wasn't. Okay? So if a perfect square, I'm going to add this, if perf square, like, is that a good abbreviation? Okay? If it's a perfect square, then those solutions are rational, meaning they can be written as a fraction. So either a whole number or a fraction. Okay? If the discriminant is positive but not a perfect square, then our solutions are irrational, meaning we're going to have a square root in our answer. Okay? So if the discriminant is positive and a perfect square, they're going to be two real rational solutions. If it's not a perfect square, we're going to have two real irrational. So two things. We got the real and the rational, or the real and the irrational. Okay? And a picture of the graph would look something like, you know, a parabola that crosses the x-axis twice. That could look any number of ways. And that one is terrible. It's like slanted that I did. But, yeah. Basically, it's going to look like a parabola that crosses the x-axis. Okay? Okay, if b squared minus 4ac equals 0. So that was the last example we did. We had one solution, so one real, and would it be rational or irrational? Rational, because square root of 0 is 0. So this will be one real, rational solution. So one real, rational solution. And pictorially, what that looks like is something that has its vertex on the x-axis. Right? If it has one solution, the vertex would be sitting at the x-axis. Okay, and then b squared minus 4ac is less than 0, a negative number. That's example 3. No real solution. No real solution. And we'll talk about what kind of solutions those are tomorrow. But that would just look like a parabola that never crosses the x-axis, right? Just something that never touches. All right. Okay, so here's why sometimes we would want to do this, okay? For examples 5 and 7, we're going to evaluate the discriminant and determine the number of real solutions. Okay, so can I customize the size of this? Oh, I can. Awesome. Okay. All right, so I'm going to do this for example 5. So b squared minus 4ac equals, and I'm going to write what that is when I plug in those numbers. So negative 12 squared minus 4 times 1 times 36. So we write the substitution step. Okay. And then we plug it in. It's 4 times 1 times 36. Okay? And that gave me 0. So the discriminant is equal to 0. Sometimes we use a capital D. Sometimes you would write b squared minus 4ac. But whatever, it equals 0. So therefore, there is how many solutions? One real, rational solution. Okay, so two things to answer that question. The fact that the discriminant equaled 0 and that there's one real rational solution. Okay? And if we do that for a 6, I'm going to rewrite this. B squared minus 4ac would equal negative 12 squared minus 4 times 1 times 40. Luckily, all I have to change in my calculator is just c, right? Okay. So for this one, the discriminant equals negative 16 So that means there are no real solutions. Okay. Gee, I wonder what the last one's going to be. Yeah. All right. That's x squared minus 12x plus 30 equals 0. So, oops, I can't shortcut. B squared minus 4ac is going to equal negative 12 squared minus 4 times 1 times 30. Which is 24. Okay, so we know that there's two real solutions, but are they going to be rational or irrational? Is 24 a perfect square? No. 25 is, but not 24. So we would say there are two real irrational solutions, meaning I know that there's two answers and that there's going to be a square root left in the answer. Two real irrational solutions. Okay? So sometimes we want the whole shebang. We want all of it. We want the whole thing solved out. Sometimes we just care about what kind of solutions there are. Number 6, discriminant was negative 16, so there's no real solutions. Okay, we finished that.